Hello students, welcome to Organic Canvas. Let's see how many statements are correct for the given different reactions. First, let's see what are the products we are going to get, then we can read the statements. The reactant is same molecule, right? It is treated with different reaction condition. One is simple addition of water in acid medium. The other one is borane in tetrahydrofuran, that is a solvent, followed by the peroxide in basic medium. Then the third condition is oxymercuration, demercuration. When you look at all these reagents, you should know that the alkene is converted to alcohol. But none of the alcohols are same. They are all three different types of alcohols. So remember, whenever we have simple water in acidic medium condition, there is a possibility of rearrangement of the atoms in the molecule. What does that mean? The first step is the attack of pi bond on the acid. Therefore, it will undergo Marconi-Kawas addition to form a carbocation. And the formed carbocation here is a secondary carbocation. Whenever we have a carbocation, it mostly will undergo rearrangement to form the stable carbocation if there is possibility only then, right? So then we are going to get a tertiary carbocation. Look at this. This is tertiary carbocation. Tertiary carbocations are quite stable and therefore you are going to get a tertiary alcohol, right? So X is a tertiary alcohol. Let's write down that also. Right? Now, let's see the second reaction condition. So remember, whenever it is treated with borane followed by the hydrogen peroxide, it's anti-Marconi-Kawas hydroxylation. That means what? Hydrogen goes to the carbon with less number of hydrogen on the carbon. So you have to remember this particular statement. So hydrogen goes here, OH goes here. This is anti-Marconi-Kawas hydroxylation, right? And what sort of alcohol it is? It is a primary alcohol. So let's write that also. So Y is a primary alcohol. Now let's check for the third reaction. What is the third reaction? It's the same molecule reactant, right? But it is treated with oxymercuration, demercuration reaction conditions. That means what? No way it will undergo any rearrangement. It simply undergo Marconi-Kawas hydroxylation. No room for rearrangement here. That means hydrogen goes to the carbon with more number of hydrogen here and oxygen, that is OH, will go with the less number like this. And what sort of alcohol it is? It is a secondary alcohol. So let's write that also like this, right? So we are getting three different alcohols. Remember, with water in acidic medium, possibility of rearrangement. These two, no rearrangement. But one is anti-Marconi-Kawas hydroxylation. The other one is Marconi-Kawas hydroxylation. Now, let's read the statements. Z is a primary alcohol. Is Z a primary alcohol? No, it's a secondary alcohol. Y forms immediate turbidity with Lucas reagent. So for this, you should know the reactions of alcohols with the Lucas reagent. Only tertiary alcohols will react with the Lucas reagent to form immediate turbidity. That means, is Y a tertiary alcohol? No, it is not. It is primary. So this is also a wrong statement. X is secondary alcohol. Is X a secondary alcohol? No, it is tertiary. Therefore, this is also wrong statement. Both Y and Z are secondary. No, all of them are different, right? So you can immediately eliminate this also. Now, all the alcohols change the orange color of acidified potassium dichromate to green to give the green color under normal conditions. This is not correct. So usually primary and secondary alcohols are the one which are going to react with the dichromate and they change the color from orange to green. Whereas tertiary alcohol cannot react with the dichromate. So this is also a wrong statement. Now, how many statements are correct here? None of the statements are correct. Therefore, the answer here is 0. 0 statements are correct. So this is how you have to correlate the products and the statements given for the question. Thank you for watching this video.